we are going to implement the state machine, and I have no idea what the quality of the audio is going to be like. I think there's a chance that people can hear what I'm saying, but they may also be able to hear what you're saying. So there's a warning: if you feel uncomfortable about having your voice recorded, now is the time to leave the classroom or just be quiet. So we'd like to implement something like this state machine here. And I'd like to suggest to you that, if there's some interesting implementation option, we can talk about that as we go, then, well, let's go for that. So last class someone asked about how about this, basically resolving names of states and so on. So we could try to do a model here where, so in my model here, the transition points to a state. It refers to the state object directly, whereas in the implementation I provided you, I use names for it. So in that implementation I don't have to do this name resolution step when I build the state machine, but with this model here, which I think we should implement, we have to figure out which state object should this transition point to. So we will need to do a little work to do that, because a transition might refer to a state that is further down in the program. So when we're building the model, you'll see this, then we might run into a problem. We don't have this state object available yet. So we will have to devise a way to deal with that. But let's get started here. So I'm going to make a new Java project. And this is state machine in class example. And I think the rest is fine. And let's just close all for now. And so right now we have, I'd like to start with one thing here. I'm just going to, make things simple, I'm going to go and grab a state machine. We're going to take the microwave oven because it's really simple. So I'm just going to copy this so I won't have to type it again. So let's make a package that state machine example. Oh, and actually, let's state machine example dot examples. And in here we're going to make a new class, which is going to be the microwave example. Microwave machine. And I'm going to use the same extends thing here. So the fluent machine will be that's going to be my builder, and it's going to contain some different functionalities such that these names are defined that make sense. So this would be the state machine that I would start by implementing. There's no extended state, but we can easily add that later. We don't need to have extended state to begin with. Does this look like a reasonable starting point? If there's something you'd like me to add for the initial one, then now's the time to let me know. No? Okay, so this is what we're going to implement. And of course, what we want to do is to go from, there are two steps. The first step is to go from this code to an instance of a meta model. And the second step is then to assign a semantics to the meta model by saying, oh, how do we actually execute this thing? And we could, there are different options here, but let's start by defining just the representation of our meta model. So let's do another new package and let's start meta model. That's a good place for meta model. And so we want a state machine. Now if we go look at, oh, it's actually always called machine meta model. Let's use the same name as in the diagram. Machine meta model, like this. So we have a machine meta model. So it's this thing I'm going to implement now. I'm going to skip the variable because I'm waiting with the extended state. So a machine meta model has a number of states, and each state has transitions. Okay, so private list of states equals new, let's just do it like this, array list of state. You can just look at this, that feels better. Should be fine, right? And yes, let's create a state class. And the state has a name and a number of transitions. Private list of transitions. I just need to. Okay, it's better. Going back here. Import list. Okay. And our state. We need to create a transition class. Now, of course, at some point here you have something you'd like to have done differently or you have questions about, then you need to ask. Since we don't have the extended state machine yet, the condition and the effect, I don't need to add them right now. Conditions always have to do with the extended state, and effects have to do with the extended state as well. And we can do it later, but for now I'm just going to build this up such that it does the microwave, and for that I don't need it. So we just have private string events, like this. Okay, now this is actually our meta model. We of course need constructors and infrastructure and so on, but we're getting there. Now we actually, this is jumping ahead a little bit, but in the state machine that I provided, and I think also, well, we don't really say it here, but there's the question of how we implement the process event method. Now the way I implement the process event was by embedding actually the logic of the state machine into the state and transition classes. I think that's the simplest implementation. But you could argue that I'm actually mixing, suppose I don't want to run the state machine, suppose I want to generate code from it. Then why does the meta model have functionality to execute itself? So we could consider whether the process event should be inside the state and transition classes, like the example that I provided to you, or if you want them to be separate, to live in sort of on this side of the object diagram. And there are different ways of doing that. I think we could cleverly put together a visitor-like thing that would go into the various objects in the state machine and interpret them by running around in the structure. We could also do just write one big interpreter method that does it, or we could distribute them across the different classes here. Any thoughts on which direction we should take? We can have a vote. So there are three options, I think. Option one is to do the simplest thing, which is also what I did in my example, which is to put event processing inside the state and transition classes. Option two is to do something. You know the visitor design pattern, right? No? Yeah? So when I say visitor, it's an object that you can pass to state and transition classes, and they just say, okay, I'm a state, do what you want. And the transition class says, oh, I'm a transition, do what you want. And then all of the logic of interpreting is put inside the state machine, or inside the visitor. If you instead wanted to generate code from it, then you would have a code generation visitor that you would give to it. If you wanted to print it to the screen, you would have a print state machine to the screen visitor. So you can do different things with the same visitor. And the model doesn't know about these things. The third option is perhaps also relatively simple, but less object-oriented somehow, which is to write one big process event method in here. So simple object-oriented, just put the process event in state and transition where it belongs. Let's keep it simple. Let's not do anything rash and dangerous. The visitor, which is more exciting, but also I haven't tried it before, so that would be more exciting. Or the big bad process event method. So who votes for the first option? Nice and object-oriented. Okay, 1, 2, 3, 4 people. Who votes for the mysterious visitor option? More people. Okay, let's...
I don't mind mystery.
If we have time, we can do both. Okay, that'll be interesting. I haven't tried that before. I think it should work. So, in any case, but we haven't gotten there yet. So now we have something exciting to go for. Right now we have to build up the thing. We have to build up the state machine from these methods here. And of course, I'm going to need a constructor. So let's generate constructor using fields and like this. And then we want public void add transition. So we want the ability to add a transition. Transitions.add t, like this. And right now I'm not going to put anything inside it to access the meta model. We can also do that as we need it. Machine meta model. I probably need to be able to public void add state. Oh, what did I? Yeah, no, it should be state s. Add this. And a transition. That just needs the public transition string event, like this.
Target state.
Target state? Oh, yeah. We're missing something. Yes, good point. Thanks. We have the two. Yes, it did seem a bit simple. Thank you. So actually we also need state target. And I think we want to state have that as well. And then this dot target equals target And let's be nice and Java-like and make this private as well. Okay, good. And now we'd like to, of course, we want to bridge this code to that code. So let's keep it. I mean, there's always the question of how many packages you want, but logically, I mean, we have examples, we have the meta model. The meta model could be used from many different parts of our language infrastructure. There could also be something that reads an XML document and populates the meta model. So I'm going to make a separate builder package here. I mean, in the end, I might only need one class in here, but this is where I put the Fluent machine. So new class, Fluent machine. And now we can fix our import like this. Okay. And we have this hook method, which I think is we could actually make it protected here. So, you know protected, right? Protected, you often use that. Actually in Java it's a little bit, protected means subclasses can see it. If you're inside the same package, then everyone can see it as well. But if you're between packages, then protected means that subclasses can see it. Protected is often, I like to use protected because it also indicates an intention. It clearly indicates the intention that subclasses should override this to provide functionality. So that's why I'm putting protected here now. So, and this is going to be an abstract class. And it's going to be abstract, of course, and a class abstract because protected abstract built like this. Okay. So whoever, obviously you would need to implement this because it's an abstract method, but it's meant to, you could also, even if the method wasn't abstract, sometimes you provide a default implementation, it's called a hook method, and with an implementation, but then you override in a subclass. And then protected also nicely indicates that, well, this is something that a subclass should override. Okay, so we have now the method state. That failed. Hello? Lots of snow in your area as well?
No.
That would have been the perfect excuse.
Lake trains.
Oh, fair enough. So, protected. Let's just think here. Now we have I mean, there's some different options here. Now, because we could create a new kind of object that here I just used the state method. So the state method returns something, and it's relatively easy to just thread this object through it here. But it also means that it's the Fluent machine instance that we're going to be threading through it. That works for me. If I had done something like machine like this, then it could have been any object that I create an instance of. So I think I would just go like this because it makes the internal DSL a bit less noisy. I mean, it doesn't have the machine thing. It just says these are the states and the transitions. But it's a design decision. So right now, if anyone would like this to look different, now's the time. Okay. So now my first step is going to make this legal Java code. So then we're going to do protected Fluent machine state string name return this. We go back here. Now this one works, and then we have the transition. Oh. Protected Fluent machine transition string a event, return this, and protected fluent machine 2, string name, return this. Let's go see. It is not very happy. Not visible. Why is it not? Did I do something? That's annoying. I thought I cleverly could use protected here. I think I need to read up on the Java visibility rules again. It surprises me. Well, anyway, now they're public. Let's not make a big fuss out of it. So, this code is legal now. So all that's remaining now is to build up the state machine. So let's have a state machine to build. So private machine meta model equals new machine model. So I can't use the fluent machine to build more than one state machine with this design. I think that's okay. And we could add a method here, public machine meta model get model. And I'm just going to do like private boolean machine. Let's not do that. We could definitely we could do to track if people try to, I don't know, access something before, like if in the middle of building a transition and then you try to get the state machine. But let's not worry about that for now. Okay. Now, so what we have to support now is that I say state and transition and so on. Now, one challenge here is that we're going to say state inactive, call that method. Now, in the implementation that I provided to you, I would create actually the state object as soon as I could, and also the transition object. But in this case, the transition object needs a reference to the cooking state, and we haven't created the cooking state yet. So we need to collect information about what we want the state machine to be like before we can build it in the end with this design. Or we would need to go for a different design. So do you want to stay with this design? Or do we want to, that's going to complicate our build a little bit, but gives us a more simple meta model. So it's again, it's a trade-off, as we often have them when doing software development. So do we stick with this? People are happy with it? Okay. What we need is, now we're just going to, we're not going to think for an hour here, but we're going to think just for 2 minutes to avoid me programming for 20 minutes in some direction that doesn't work. So we need to collect information about states and which transitions they map to. Now, one way to do this is to, because we can create the state objects as we go along, but we cannot create the transition objects until all state objects have been created. So we can have a map string state that we use when we build, and I can put states in there because then I can look them up afterwards. And then I need some way of storing my transitions. So I could do something like, we could have a class. I think that might be because for transition we need to know two things, the event code and the name of the state that it goes to. So we're going to have a class transition info that has this information, because I can't create the transition object yet because I don't have all of the state objects yet. And then we're going to have a map and transition info. So this has event and state name. And then we can have a map from state to list of transition info. Does this seem like a reasonable representation? So we built this, yeah?
More simple thing could be you say that we don't have the state when we arrive to the 2. That's right, but why don't we just create the state and put it up on the machine meta model in a list, and when we then arrive to creating the state, then we just look up in the list and see if it is there. If it is there, then take it and then we can use it. Instead of waiting.
So you're saying we can also
because we stores all the states
okay.
Anyway on the machine meta model. We have a list of all the states.
So you're saying when I get to the 2, if I reach a state I haven't seen yet, I will just create the state?
Create it, yes.
Okay.
And then you can, yes.
That's a much better solution. Very good. Okay. So I think I could have programmed for half an hour and eventually gotten to that solution as well.
But you do that in your solution. You save all the states when you do it.
Well, it's a number of years since I wrote it, so I had forgotten about that again. Okay, good. Thank you. So we'd like to use the machine meta model to also we'd like to public state get state string name, and this also points to a different representation actually of our states here. So let's make that a map string from string to state, states equals new hash map, like this. Okay, it's let's start get name, and let's add a get name class string return name, like this. Get state output. Sorry. Okay, and then we return states.get name, like this. Okay, and so when we get to state of a given name, then we do model.add state new state name. Like so. When we have a transition, this means we need to create a new transition object. And we probably also want to know what are the so private state current state, private transition current transition, like this. Second, I was a little bit too quick here. So current state is then a new state object, and we add this here. Okay, if we have a transition, this means we need to create a new, actually we can't create the transition object yet. So we want to say current transition 2 equals events equals event. Just have this instead, current transition events, like so. So when we get to transition, we remember that, we want to know that it's the state event. And then when we say 2, that's when we create the transition object. So that's actually the most interesting part. And this is the name of a state that we pass here. And so we want to say state equals model dot get state name. If toState equals null, this was your insight. We can just create them on demand. If toState is null, then toState equals new state name, and then we remember to add add it to the list of states. So model dot add state to state, and now we can to the current transition to the current state. So now we can say transition t equals new transition current transition events. So that's the name we just recorded from the to method and the to state. And then we can do current state dot add transition t. So that's the basic machinery. It doesn't actually work yet. There's a number of things we're missing. But this is the basic thing we need to do. So when we call the state method, this means create a new state object. When we say, oh, there's a transition, like here, this means we just remember this information because we can't do anything yet. Then when we get to the to method, we have all the information we need to create a transition object, and so we do that. And we cleverly remember that, oh, if we haven't seen the state yet, we can just create the state object now. So there's a number of things that at least I right now can see are broken here. Oh, that don't work yet. So the code we wrote is fine, but there's some cases we haven't handled yet. Does anything come to mind for any of you? Yeah?
I believe we have to also flush at some point. I know, I remember I had to do it because otherwise
yes.
it will...
I think often when I've made these things, I forget about it, and then it breaks horribly because I didn't think about it. So we have to at least be careful about what happens when I call because when I call the state method here, I need to start working with a new state. And in the way I did my builder in the other class, that was certainly necessary. Let's see if it's necessary here. So we have current state and current transition event. So I assume here that state has been called at least once. Otherwise it's going to fail. We could check for that. So we could say, if we forgot to call it, we can do a little bit of error checking here. So if current state equals null or current transition event equals null, throw new error, bad program. Right, and then down here when we build the transition, we can set current, because we've used this, current transition event equals null. So once I've used this, like once I've used start, I forget about it again. So I can't say start to cooking to whatever else. I can only call to once for every transition method, which I think is reasonable. If I right after to call state again, no, actually the thing that might happen is I call transition again. Well, then I said transition to something else, and then I think that actually works. So maybe it's not broken actually. If I call state, then I set my current state to something new. Well, there is one thing that's missing, which is the, or maybe, well, actually here, because I do it when I call transition, here my concern was, do I get the last transition and the last state in there as well?
You get that.
But I think I actually do, yeah, so maybe it's not broken actually.
You get that.
Yeah, because I added here. By the way, it's because here in this implementation I added early on. This is actually a better implementation than the one I gave to you before. That's okay. I think this actually looks good now. Yeah. And we can call microwave machine, and the fluid machine here has a get model, and of course we could make sure to call this.build and then return the model. So we build and then we return the model that resulted from it. So let's make a new class. Or do we want to? So do we want to? So in my examples, I always put I had a separate main class, but let's just put the main method in here. Is that okay? Or would you like the main method to be in a separate class? So who votes for main method right inside the microwave machine? 3 people. Oh, 5 people. Okay, who votes for a separate class? Only 4. Ah, so close. And if some of you didn't vote, then remember your vote could have made a difference. It's always important. Public, static, void main, string, argv like this. Then we do microwave machine equals new microwave machine. And then we have machine meta model equals machine dot get model. Yeah. Okay, so now it's the exciting point. Let's run it. That's my oh, maybe there's no success. It works. Okay, we're done. Right? It's good. Maybe it would be nice to be able to print the meta model. So let's make this visitor thing I talked about. Okay? The visitor design pattern, I'm assuming you don't know the visitor design pattern. So the goal of the visitor design pattern is to separate operations from data. It's slightly clunky in a language like Java, but it can be useful sometimes. So let's try it here. And I'm going to put it inside the meta model because it's part of this data structure. It's a facility that it supports. So let's make a new interface. And let's call this machine visitor. Now, machine visitor is something that can perform operations on the meta model. And so it has an operation for each of the data struct classes that are in there. So it has a visit. So it's a little bit, I'm not sure if here we want something for visiting the top level class. I'm just not going to do that now. We can also extend it later. So visit state. So this method will be called on state classes from our model. State public void and public void visit transition. Okay. And the way the visitor pattern works is that each of these classes here have a method called accept, and it accepts a machine visitor. And now there are many different ways of doing the visitor. I'm going to do what I think is it's a little bit tricky here. Let me just do one version now, that because I haven't completely thought about how to execute the state machine using the visitor. So I'm just going to make a simple visitor now that works for pending. So basically what we do here is we do visitor.visit. Come on. Right. Here we go. Visitor.visit state. This. And now I'm going to, our accept method here is going to, so at first it calls, oh, here's a state, and then for each of the transitions it's going to, or maybe not. I'm just going to leave it like this here. Public void accept, and then we have and here we have, so this is going to visit transition, like so. And now I'm going to make a facility for printing the print visitor, and it's going to implement the machine visitor interface. Okay, so the print visitor, the role of the print visitor is to print the state machine. And it's simply going to do that by printing out, so system.out.println state plus state.getName. So, and now there's a few different ways of doing the visitor. Here my visitor does not automatically go throughout the entire state machine. So here I need to do a bit of work to make it go to all of the parts of the state machine. So it's actually maybe not the best example of a visitor, but so let's just do for or I'm just going to jump back here. I'm going to the for transition T in transitions T dot accept visitor. Okay. So we're going to print state and then on or events plus, and then the transition that does it have a get event? No, it doesn't. Well, it will now. Get target state dot get name. Return events, and we also need the public state get target return target. Okay, I think this shows you a little bit better how the visitor works. So when I implement a visitor, I just say, so for each kind of element I have in my structure, here's what to do. When you get to a state, print out state like this. When you get to a transition, print out something like this. And so the way I use it is then I can do model dot, actually I think we also need an accept. So the model here should, I think the public void accept machine visitor visitor, and then we're going to for states s in states that gets, what's it called, get value set values, there we go, s dot accept visitor. Okay, and now we can do this thing. So the visitor is a bit of work setting it up, but then to print, use my print visitor, and I'll do that accept new print visitor like this. Okay, let's try this. Okay. So what's nice here, and which is different from what you maybe, how you sometimes do these things, is that there are two things to say about this. I didn't put the printing functionality into each of my data classes. The state and transition and model classes don't know anything about printing. They only know about the visitor. And there could be other operations. I'm not entirely sure I can shoehorn the execution into it, but there are other, if you wanted to serialize to XML, or if you wanted to go through all of the states and check that the names were consistent or whatever. There are all kinds of things, operations you could do that a visitor could implement. And the other thing is that so it's not inside the structure, and I don't have a whole bunch of ifs. That's not like if it's a state class, then do this. If it's an transition class, then do that. So it's more object-oriented in a sense. I'm using, it's actually a technique called double dispatching. So inside the, it's like here. So as soon as the visitor calls me, I call the visitor back. Say, oh, I'm actually state class. So we get, it uses a virtual call at virtual dispatch to find the accept method inside the state or the accept method inside the transition, and then whichever accept method was picked, it calls the visitor back and tells it which one it was. That's the visitor design pattern. And it's one way, it's a little bit, it has advantages and disadvantages to it. Now it's very easy to add new operations. I can add as many new operations as I want to my data structure in the form of visitors without adding new methods to my data classes. On the other hand, if I ever add new classes to my data structure and I have a whole gazillion of visitors, I have to go modify all the visitors, which is a pain. There's no free lunch. Read up on the visitor design pattern if you don't know it. It's a nice pattern to know. And it's it does a nice, there's a nice object things in it. Anyway, this was kind of a sidetrack, but I thought, well, if you haven't seen the visitor design pattern before, now is certainly the time. It's part of your general education. A recommendation on this, there's a book back from 1994 that introduces the concept of design patterns. It's called Design Patterns, Gamma and a bunch of other authors. It's called the Gang of Four book because it's of a famous book, and this is where scientists popularized design patterns. It is the one book that taught me the most about object-oriented programming. I feel like I didn't really understand object-oriented programming until after I read that book. So it has a strong personal meaning for me. You might be better off because we teach things differently now compared to what we did back then, but it's really good. If nothing else, check it out, the library, and read it. It uses C++ and Smalltalk and other languages because Java wasn't invented back then. But I think you can still, I think you know enough that you can read the code. And there's some very nice explanations of how to do good structures in object-oriented programming. I think you're at a level where it makes sense now, so it's a recommended reading. Anyway, we now have the state machine. We build it, and we can also print it again, which is a good sign that we built the model in the right way. So now we have to go and execute it. I'm thinking it might be good with a break before we do that. So let's do a 10-minute break and pick up again at 10:13. The recording is going to be the longest YouTube video ever. Or maybe not, but so it's okay. Yeah, it's fine. We now have the ability to define a state machine, to build it, and to print it. So now we want to be able to run it. So let's go look at our class diagram. So we want to know what is the current state and what is our extended state variables. And here we just want the current state, of course, because we don't have any extended state variables. So let's go do that. I'm going to create I'm a little over-organizing it into packages here. But I'm doing that deliberately because there's sort of different aspects of the system. And examples, that's where we would put concrete examples of state machines. The builder is the thing that builds the state machine. The meta model is what sits in the middle, and then we can now have an executor. I could also make a code generator, for example, package. But I'm going to make an executor package. And it's sort of overdoing it because we're going to have some packages that only have a single class in it. But this is just to separate things out clearly for you. So execution. Right? Okay, it looks better. And let's see, what did we call the class here? We called it state machine executor. So let's make a state machine executor. New class state machine executor. And a state machine executor has a private machine meta model machine. No? What did I call it? Does anyone remember? I did call it machine meta model. Okay. And then we have a public void process event string event. This. So this is the method we want to be able to implement. And then we have a private. So I think it makes sense here to use the state class to. So here's an implementation choice again. How do we want to represent our runtime state? We can represent it as a string, the name of the current state, or we can represent it using a state object, which is the current state. So either the name of the state or the state object. The question is just, what do we put inside our state machine executor class? What is the, because in the end we could imagine that the only thing we know in here, that's the name of the state and the integer standard extended variables. Then we completely decouple things somehow. Although we do have the model setting there. But we can also keep links to things inside the model when we execute it. That's also fine. So we have a vote again. That's the advantage of showing up here. So people who might be on YouTube, of course, don't have any say in this. So who votes for using just a string, which is the name of the currently active state? Okay, 4 people. Yes, good. Be proud to vote. Who votes to keep a reference to the state object that corresponds to the current state? 5 people. Private state. This is an excellent lesson in democracy. Private state, current state. There is actually kind of one thing missing here, which is that I don't know what is my initial state. I don't remember exactly how I did that in my example. I think we should make it explicit here. I think a machine meta model should have public state get initial state. Return initial state. And this is a special one. We have private state initial state. And I'm going to have the convention that whichever state is the first one we add is also the initial state, just to keep it simple. So you say if states dot size, yeah, equals 0, initial state equals s. There could also have been an explicit "this is the initial state please" method in our builder interface, but we're just going to say it's the first one. It's not entirely uncommon. So now we can say we have a concept of an initial state. Of course we should, our print visitor should print this information. Okay, now I'm actually, so in machine visitor I didn't put something to visit the machine as a whole. And this is slightly annoying. Well, we know that it's the first one anyway. Let's just leave that for now. Current state, and let's import that and have a constructor public state machine executor machine meta model machine. And then we say machine equals machine like this, and current state equals machine dot get initial state. So the machine is ready to run. Now we get an event. I'm just going to try. Now this is where the I'm just going to try something here. I don't know if it works, but I'm going to see if I can make this be a machine visitor. So when we process an event, this means we need to, the current state needs to process it. So we could say, there's a little bit of redundancy here because we know which state it is already. Let me try this and then we can see what it looks like afterwards. So current state dot accept, because that's all we can do. This private string. This is the current event. So this is the event that this is the last event received. Current event equals event. Now visit state actually isn't going to do anything. I'm just going to leave that empty because we already know which state we're in through the current state. And then the visit transition method is going to be called for each transition. So here's this is an experimental, there will be pros and cons of the solution. So we know we want to say that if transition.get event that equals current event, current state equals transition dot get target. Now there are pros and cons, but I think this actually works too. So let's just do something. We could do something in print system dot out dot println in trace in state plus state dot get name plus received event plus current event. Now this is a slightly different trace, so this is going to do something slightly different in some cases compared to what you've seen before. If I have many matching transitions, but I probably don't have that here because I don't allow that anyways. I think maybe it's okay. Selected target state plus current state dot get name. I think this is an interpreter for the state machine. So let's try it out. Then we can look at afterwards how it works. Model.accept. No, wait. Machine executor. State machine executor. Exec equals new state machine executor model, like this. And we're just going to send it some events that I'm going to hardcode into the program. So exec.process event start and exec.process event stop. Just to do something simple now. Okay. See if this works. Okay. So first we do the print out like we did before. Now we run it. in the state inactive received event start, we select the started state cooking. In the state cooking, we received the event stop. And then it didn't. I would have expected to say selected. So why didn't that work? Oh no, it shouldn't get there. It should. Wait, in state cooking, select stop.
So we're missing a stop, right?
Yeah. But why? Okay. I have no idea, so I'm just going to do a little bit of interactive printf debugging. If any of you have insights, then please let me know. So this is if it matched, else. Let's do a print, another trace here. Trace, not selecting state transition dot not selecting transition to state, not selecting not. Okay, so not, this one doesn't match. So not events transition dot get event. So not going to state transition dot target get target. Okay, so now I'm going to my visitor will always print something. That should make it easy to understand. Now there's of course a debugger built into Eclipse that I could also use. When you have something like this that runs something over a longer time, it can actually be hard to figure out what's going on looking at the debugger. I often like to do something like this that builds a trace.
I don't know. I think I know what the error is.
Okay.
Because I also have that.
Okay. So
it's because if you're doing the loop, then you need to you go into the last transition, but then you need to print from your main method the last state, because you never reached that. You never reached the visit state for the last transition. And that's why
yeah. So it did work. We just couldn't see it.
Yeah.
Okay. So public void. Let's just make a print current state, right? System.out.println trace current state is plus current state dot get name. So that's the hypothesis. I think that's true. Exec dot current state. Nope. Is it? Wait. So inactive received event start, select state cooking, in state cooking received event stop, current state is cooking. So
it's another logic error in maybe in the
not selecting states.
No. Which is also kind of surprising, right?
Yeah.
And I know my meta model is correctly built because I'm printing it like this. Let's take a look here. This is the point where I often have a break if I have no clue what's going on. So it seems that visit transition is only getting called but it should be calling them for each of the subclasses here. What you do is transition and I'm just getting paranoid here. Let's see this. We want to see this happening lots of times. Okay, there seems to be something.
Only one time.
So state, okay, transition, state. I'm getting desperate here, so I'm going to make a two-string class. Public string, two-string. Return states class name. And we have transitions.size.length. Okay. Okay, so cooking doesn't have any transitions.
So maybe it's the Fluent API that the logic from the two.
Yeah, but then this one seems to indicate that it does have transitions. I think I know what's wrong. You know, there's this. Things get worse and worse until some point. I'm pretty sure what's wrong. Now, some of you have taken my class on operating systems and networks.
Long time ago.
Yes, and there's this thing that I keep saying, oh, you must do this thing. Otherwise, you are not a good software engineer programming Java. You will get weird and horrible problems if you don't do this thing. It's really important. So what's important if you want to use, I'm guessing here, I mean, no, maybe not. Maybe not. Sorry, for a minute I was thinking we were missing an equals and hash code methods, but we look up get state. I think what's wrong is that the model is being built wrong. I think because we could have, there's a risk that no. Actually, let me get back to And we are getting close to the point where we should have a break. Actually, let me get rid of this. So right now my guess is that I'm building the machine wrong. So let's just okay, so cooking has this hash code here. And here it's different, right? So what's happening is that the clever thing that I agree is the right way to do it somehow isn't working here. I'm building my model wrong. The reference, I have an inconsistent reference, right? So this transition here has a link to, and let's just to make it completely clear.
Yeah, okay.
Plus.
Isn't it because when you call transition twice on the same, the state object is gone?
Just a second, I need to transition.get target. Just run this again, so maybe it's even more clear now. So cooking is here, and this one here, this says go to this state here. Yeah. So event start goes to the cooking state, which is this one, but the cooking state is a different state. So they have the same name because I'm cleverly printing the names, but they're different objects. So I have an inconsistent meta model. And of course, when I have an inconsistent meta model, then nothing works because I'm trying to interpret something that is not really what I want. The meta model that sits there has start takes me to the wrong cooking state. The wrong cooking state doesn't have any transitions, so of course nothing happens. So the problem here, and this I couldn't see this because I was only printing out the state names. So the problem is in my Fluent Machine interface. Now, of course, this kind of thing goes with the Fluent interface being kind of complicated. The upside is that once we fix this bug, so long as we use the Fluent interface, our models should always be consistent. Like this kind of problem, which you can see how horrible it is to debug, we will not get that if we have a structured way of building a model, which is what the Fluent API gives us. So, please help me debug this. Why doesn't this work? So current state, and we add this to the current state. The to state, we ask, so what's going to happen with the cooking is that we try to say, oh, the to state, oh, I forget to add it here. Right? So I have model dot add state, the to state. Oh, I have that. No, I have that. Sorry.
I think it's in the state method. Because you don't check if you already have that state from the to method.
Ah!
That's the
Yes,
thing.
yes. Thank you. Excellent. So actually I should try first to look it up, right? So I say current state equals model dot get state of that name. If current state is null, current state equals new state. And it works. So current state is inactive. And the model is now, this is a transition to this one, and it's this one. So, the model was built in an inconsistent manner, creating all kinds of horrible problems that were difficult to debug. Thank you. We solved the problem. And of course, maybe the lesson here is that, I mean, it's nice to have a thing that prints out your meta model, but if you print out the meta model just with names, then you don't catch something like this. And there really should have been something that maybe checked the integrity of the state machine model. I could have added sort of an integrity checker thing to my, I could probably do that using a small visitor. So let's backtrack. I'm just going to, so machine visitors like this, transition and state define. The print visitor just going to put that in square brackets here, and I'm going to keep these because they were kind of nice. Right, that's okay. My state machine executor. Okay, I don't think I need quite that much output. So, but let's say here private boolean trace, because tracing can be nice. As a detail trace. Public void set detail trace. Let's make this. Here we say if detail trace and if detail trace, and we run again. Okay, now this thing is not quite as readable, but here let's look at oh, I have some, oh, here, sorry, try again here. So in act state inactive received event start, in state cooking received event stop, current trace is inactive. So we went from inactive got start, cooking state got stop, back to inactive. The way I implemented my executor here was to use the visitor as promised. It's not the most elegant use of a visitor ever, but basically we say, oh, whenever you get to state, just print out what is the current state. We could have here also said that current state is this state, but we already know what current state is. So this works with the other ones. The transition, so this is mostly just so you can see what's going on. The transition here means it automatically takes us with the for loop defined in the visit in the accept method of the state class, go for each transition, and then we say, is this the right one? Then, well, the current state is this one. This means that if there were multiple transitions all with the same state, or with the same event code, we would take the last one. So if in the cooking state we had two different transitions that reacted to the stop, we would take the last of the two. in this case, since we don't have extended state or conditions or anything, I don't think we should have two states with the same event code. So whether we take the first one or the last one, I think it doesn't matter here. It's kind of sort of an undefined behavior. So I think this is the example. We have the meta model defined by itself. I put the printer in there, but it knows nothing about how to be executed. The executor here has all of the execution functionality. The builder knows how to build a meta model, and now it knows how to do it correctly. The state machine here defines a state machine and runs it. I could make a loop here that would read line, and we could interactively type events, but I don't think we need to do that. So the question is, what should we do now? We could add extended state to this, or we could do something else, or we could stop now, or whatever. So any thoughts on what could be useful? Yeah?
I'd like you to add extended states.
Extended states? Then we will add extended state. So let me grab another example from up here. Let's take the cooking hood, right? Our favorite state machine. Here. We can see if we want to keep the definition here in the same way, or if we want to make it different. So let me just do the cooking hood machine. I'm just going to rip the innards out of this one, and let's just grab the definitions from here. I think that's okay. So, I think I might skip the otherwise for now, if that's okay. So I would do it like this. Just to make the building a little, we can always do the otherwise if you wanted to. So on plus to max power when state is equals to this, and to max power, wait, to power, I guess this is going to be a self transition. Yeah. So if we get plus with max power, no, transition, we go on a plus, we go to max power when the state is equal to max power. On a plus, we go to power on, that is, we stay in power on, but we change the state by 1. Like this. Does that seem reasonable? So let's here. Now the other thing we need now to have extended state is to know something about extended state. So let's make a private set of string variables equals new hash set. So in my model, I'm just going to record what names of variables do they want. So going to have a public void add variable string v, so I can add a variable to my machine, variables.add v, and I can public set of string get variables return variables. And so I have this method integer state here. I can add that to my fluid machine. Public, this is a void method, integer state, string name, model.add variable name. So now my model can record names of variables. And that's, I don't know the values, of course, because that's not until the state machine runs. Right now I'm just recording what variables exist in my state machine. And there's the power. If I wanted more, I would just write integer state, whatever else. And now I need to implement the setState method. SetState in value. Send this. And the when state equals string variable name value, turn this and change state. String variable name int delta. So how much do we want to change it? And return this. Of course, now I need to think about how do I record this. So set state is something, in all cases, let's just look at how this works. Set state is and change state are things I do when I make a transition. So it's something that belongs to a transition. It's also possible in state machine to attach actions to states, but we're not doing that here. It makes sense sometimes because maybe no matter how you transition into a state, you want something to happen. It would be reasonable for power on, for example, power on might do some things to actually make the cooking hood start operating. So it would make sense that when you enter the cooking hood, the state, you do something. Depending on how, but there are many different ways of defining state machines. In this case, we always link them to transitions. And the when state equals is also a conditional transition. So this is something we need to add to our transition model. Now it complicates things a bit because it comes after the to. So right now in the to, I just create the transition and add it. But here I actually want to add information to the transition. So now we have two ways of doing this. And you get to vote again. Either in my builder I collect all of the information I need, and then when I'm sure I have all of the information, I create a transition object. This means when I have the to method, I can't create a transition object. I have to wait until I either call transition or state. This is like the flush thing that was in mind. Or we can say, let's not do that. Let's just do it. Sorry. Let's just make 2 be the last one. So that's the sort of a hack, right? We just change the way you write the state machine. Both of them work, because in this case I would have to remember that I called the when state equals, but when I create the call the to method, I would have all of the information because to is always the last one. That's the one that creates the transition. So, which one do we want? The nice solution where I can write it like this, to, and then add extra conditions and actions, or the easy one where I just put to at the very end. So the nice solution, who votes for that? 1, 2, 3, 4, 5, 6, 7. And who votes for the quick hack? 3 people. Okay. So we'll do the nice solution. The first thing to do is to extend our meta model to have the capability of expressing this information. And so inside the transition, now a transition here has an event and a target. Now it can also have a condition. Now again, I'm not going to represent arbitrary mathematical expressions in here. We're actually going to look at doing that for our external domain specific languages. So you will get to think about how to do arbitrary math in a symbolic way, where we use objects to represent it, but we're not going to do that now. We're just going to keep things simple, which is okay. So I think this is the right one, right? Yeah. So we need to be able to set a state, check if a state is equal to something, and we need to be able to change a state. So I'm just going to use integer object to represent them, and if they're null, it means it's not there. So set effect, change effect, and condition value, and private string extended state of operation variable. Might be null. So in a transition that doesn't have any effects, all of these are just going to be null. In this one, it says set state power to 1. So in this case, the set effect would be 1, and this variable would be power here, because that's the name of the thing I work on. So it's going to be power and 1. In fact, I could even, but this is one way of doing it. So it might actually, we could also use, there are lots of ways we could do this. Of course, we could also use, we could have a whole hierarchy of objects to represent our different operations, and then we could do a small visitor to visit them again. We could also do an enum to represent we have 3 different operations. That might be nice actually. So here I'm using the nullness of values to there will always only be one of these which has a value. Actually, there could be 2 of them, because I could both have a condition and a change and a set. Or could I?
Change effect and a condition value, and you can also just have an effect.
I could both set, and nothing's preventing me from calling set and change multiple times actually. So that's the question if I want to. Okay, so we actually have a whole bunch of choices here. So am I allowed to say change state x, 5, like this? Is that legal? I think it makes sense, right? That we can have a whole bunch of these. Do you want to support that? Yes or no? Yes? Vote! Who votes yes? 1, 2, 3, 4, 5. Who votes no? 2. Okay. So this means that what we want is we do need a bit more modeling now. Let's have a class that represents, now this is becoming a slightly more elaborate concept. Let's have a class that represents an effect, okay? So, effect, or actually it could also be a condition. So let's have an extended state operation. And then we have enum, kind, and the kind can either be, that can be set, to set the value of something, can be change, it can be equals. Those are the three things we can do. So we can set something, and then we can have private kind, private string variable name, private int value. Right? And now we're going to construct using fields, all of them, and let's just get a whole bunch of getters and setters here. Set it all. Okay. That's fast. And so when we're building a transition, we can have a list of so there are two methods, of course, needs to be changed because we don't want to create a transition object in here. We have to be a little bit careful.
Create a flush method now.
Yeah, I think I need to, this is the current state, and then we have current transition events, private string current transition target, like this. So current transition, this is the only thing we report, target equals state name. And then we have private void flush transition. It's the same pattern again. String state name, actually current transition target. Turn this. So flush transition. Whenever I call state or transition, I need to call the flush transition if, and then I said current transition target equals null. So whenever I call flush transition, I can only do it once. Then this current transition target is a thing I used to see it. So when we get to the state here, we say if current transition target is different from null, this means we're in the middle of building a transition, we do flush transition. And on transition, if current transition target is not null, flush transition. So what I say now is every time when I call the to method, I just record what did I pass there. So when I call to here, I just record it, and I don't do anything else. But then when I call the state method, that means, oh, create the transition object that we needed for this one. Or when I call the transition method here, create a transition for the previous one. See if it works. Ah, it still works. And no, Oh yeah, this is a different state machine. So power on, max power goes to, that's funny. So in state power off is there's a plus go to power on, and power on is this one. Okay. Now what's slightly funny is that the max doesn't have any transition. Ah, that's because I have to call flush transition at the end. Now?
Yeah, build machine.
Yeah. So build. This is the get model build. This is that flush transition. Try again. Okay, now Max has an event as well. Okay. Now I can, my thing still works. I haven't broken it. And I now need to handle the set state and when state equals methods. So I'm going to also have a list of effects. So these are the effects that belong to the current state. Private list of extended state operation, current operations, like this. Oh, come on, don't be stupid. Isn't it called extended state? No? Okay, and then whenever we call transition, it means that we start a new transition. So we do current operations equals new array list, like so. The transition should also be past the current operations. And now we have a private list of extended state operation, current operations. List operations equals underscore current operations. Okay. Back to my fluid machine. So when I flush the transition, when I build the transition object, I record the list of current operations. And of course, I'm not putting anything in it yet. So set state should do current operations dot add new extended state operation. Let's just go look at it. So it needs a kind, a variable name, and a value. Okay. So this is an extended, let me just do something here. Import. Does that work? Can you do static imports like that in Java? Ah, it's not called transition, it's called extended state operation. Okay. New extended operation, and this is going to be kind dot. It's a set, and it's variable name, comma value. Okay. And this is an equals, and this is a change. Okay, now I think my Fluent interface is at least almost complete. Right now I don't have any way to, I mean, when I run this, it looks the same as well, and I can't see what effects there were here. So I'm just going to change my visitor here. So when I think it would be useful to be able to visit an effect as well. So let's make machine visitor here, public void visit operation, and this is going to be a extended state operation. Now immediately, so one thing which is kind of nice about the visitor is now I've said, oh, I have a new kind of thing I need to deal with. Imagine if you had done this with an if, then everywhere there was an if, you would have to go check, am I checking everything? Now I get a compilation error every place where I'm missing it, which is nice in the sense that I cannot possibly forget to add how do you handle an extended state operation. So that's another advantage of the visitor pattern. It can also be annoying if you just want to try it out, because you can't just try it out. You can make the machine visitor be an abstract class instead, and then you can have a default implementation. So there are different things you can do. Actually, it's slightly complicated, but it's a basic trade-off of the visitor design pattern. So let's fix the print visitor first. Does anyone remember if enum has a useful toString in Java? Let's try it. System.out.println operation plus operation.kind plus this operation dot variable name. This is not a nice printout, but it sort of works. And our transition should now be modified to visitor dot. So because we have our operation, so for extended state, I kind of forget this. I regret this name now because it's very long. Up in operations, up dot visit dot accept visitor. No. I didn't do an accept there yet, so and we need public void accept machine visitor dot visit this. So let's just, we have here, it does do something useful. So we have in the state max power, if there's a minus, we set the power to 6. On the plus here, That's an equals. So on the plus event, we go to max power if power is equal to 6. So this seems just about right. And of course, I didn't implement it yet for the executor. So, but this, it builds the state machine in the right way. The meta model is built in the right way. And now here we get to a slightly now I have to think a little bit again. We can't just program blindly. Because, I mean, the way that I implement the visitor, the different ways of doing it. The visitor that I showed you is something that it's sort of like similar to, do you know the difference between external and internal iteration? Now, external iteration is the iterator interface. You ask a data structure for an iterator, and then you can have the next one when you want. But you can do whatever you want. You control when to have the next element and what to do with it. An example of internal iteration is the streams feature of the Java library, where you can say some data structure that stream or parallel stream, and then give it a lambda, and that lambda is going to be called for every element. But you don't control which order it's done in. That's internal iteration. You're not in control anymore. So the iterator I've implemented here uses internal iteration. I can't control what it does. It's going to always call all states, all transitions, all effects. So if we look at our state machine, it's always going to, whenever we get an event, it's going to go to all of them. I guess if we, in this case, like here, we would check if the state equal to, we would check this when state equals thing. And this one wouldn't have it, so I think it would actually work still with the way we do it here. But it means that our executor is always going to go through the complete list of states and all transitions, which is a side effect of using the visitor. So if I want to keep using the visitor like I defined it here, that's a downside to it. I could also make it, sometimes you have different visitor interfaces. One where you control what to do next and one where you don't. This is one where I don't control anything, so it's going to go through all of the things. I think I'm just going to try and see if we can make it work with the one that goes through all of the things. But it's going to be, it's not the best way of doing it. So here I say if transition.getEvent.equals current event, and I'm just going to use a helper method is applicable. Transition. So if this transition is applicable, then go ahead. Now, is applicable is going to, so whether a transition is applicable depends on whether it has any conditions. And if any of those conditions are false, it's not. Otherwise, it's true. So by default, it's going to be true. But now I'm going to do for, and our transition has so our transition, so for, and these are going to be extended state operation up in transition dot get dot. I don't have any way of getting that. Get operations. Get going to add this. So now I need some way of getting my operations, of course. Return operations. Okay. So if up.getKind is equal to kind.equals. So if it's an equals thing, I need to check it here. So then I don't even have my variables yet. So I'm just going to pause for a second here. Right now, when I create my state machine, I set the current state, but I don't know what the variables are. I need, if we look here, I need my map from string to integer. That is my extended state. I haven't implemented that yet. So I need this map. Private map string comma integer extended state equals new hash map. Like so. Okay, and when I create the machine, I'm going to do for string variable in machine dot get variables, and for each of these I'm going to create a variable extended state dot put variable, and so all variables have the value 0 to begin with. So this is my store of variables. So here I'm going to check variable value equals extended state dot get of up dot variable name. This is an integer. If variable value is null, throw new error. That's because it's an illegal name. So this is an undefined name. Then I need to check whether so if variable value, so this is the one that I looked up in my store, is equal to the one that I have in my operation. No, actually, so let's just look at the program here. So here, for example, I'm saying if the state is equal to max power, do this. So here say when I have a transition, go through all of the operations. If it's an equal, well, then look up the value of the variable, this is power, and compare to the value that I want to check if it's equal to. If it's not equal, return false, which means the transition was not applicable. If I've gone through all of the operations and none of them were false, maybe because there weren't any, then by default, yes, I'm happy. Let's go with this. Then we also have all of the effects. And now, I mean, here's the, right now, if there were multiple states, multiple transitions that were applicable, I would just go with the last one. If I make effects, I have to be a little bit careful. Do I make all of the effects from all of the ones that are applicable and then just take one of them, or should I just make one of them? so if there were multiple transitions that all were legal and they had different effects, like increment power by 1, decrement power by 1, should I do both of them or just one of them? Normally I would just do one of them, but then I have to be a little bit more careful in my executor here. I'm going to assume here that there's only ever going to be one transition that's valid, so I can just do the effect right away. So I'm going to say current state to this, and then I'm going to do update extended state based on this transition. So we're going to do something kind of similar. So we're going to say for each of the operations that we want to make, and we're going to, we know it has to be something to do with a variable. Just going to get that out anyway. And then if it's a set, then we want to do extended state.put up.getValue, and with the name, of course. Actually, I don't need the value here always. Sorry, and I'm going to else if up.get kind dot change. Okay. So this does an update of the extended state. If we decide to take a transition, we update the extended state, meaning for each operation, if it's a set, we do the set. If it's a change, we do the change. If it was something else, an equal, we just ignore it, because equals doesn't have any effect on how the state changes. Cooking with machine. And we have plus. It's going to be quite exciting. See what happens. It didn't completely die. Let's right now but we can't see what really happened with the variables. This is state in state. Let's just do it like this. And then I think Java might have a useful way of printing out. So it doesn't completely work. We keep power is getting too high here. So there's a bug somewhere. It seems my condition isn't working. So we get the plus. Should go to, we never make it to the max power state, so my equals operation isn't working. There is an equals operation in my meta model, but it doesn't work. So let's see if we can just do a quick fix. Value, get value. So that seems okay. Ah! Sorry. This is the thing I was kind of talking about before. So what happens is we go in here, we say state equal to 6, that's good. We do everything we want to do here, and then we go to the next one. And there's no condition on this, so we take this one instead because it comes afterwards. We always take the last one that works, and this one also works. So this is kind of, it's because I have this, I might use my visitor, and my visitor always goes through all of them. I could add an explicit like let's do this quickly to test that we can have multiple things when state not equals. Sorry?
You could just change the order so the when state equals is the last ones. That's the
that's tempting. Let's just try this. This would be a good test for our hypothesis, right? Yeah. So this way?
Mm-hmm. Oh, yeah.
Ah, it works. Okay, perfect. Okay, that's it for today. Yes. So, thanks. The better way of fixing this would be to either, one way to do it would be to have a when state not equals and put that on these ones, so they're mutually exclusive. Or to put something inside the executor such that the visit transition should keep track of, did we pick a transition? And if whenever we chose one that we want to go for, then we don't take the next one. So we could say, I think I can do this, let's try this. So private Boolean pick transition. So when we visit states, we say pick transition equals false. We didn't pick any transitions. If we pick one, if we didn't pick a transition yet, and this, picked transition equals true, like this. Let's try this. Wrong one. It also works. Okay. So now we have now we actually have a much better state machine executor, because this state machine executor will always ever go to one state, and in that state it's going to go through the list of transitions, but it's only going to take one of them. So that's it. Any last questions? I'll upload this to YouTube and distribute the zip file on Blackboard. Thank you for your patience.